So let's begin with this. सबसे पहले, you have exponents and radicals. All right. So this is the first thing that you have. It's kind of a revision of what you've done in O levels about exponents, the rules, indices rules that you've done in O levels. You need to remember them. X power 1. So basically anything raised to power 1, that remains as it is. So if you have 2 raised to power 1, that is 2, 3 raised to power 1 is 3, and so on. Anything raised to power 0 is equal to 1. Okay, anything raised to power 0 is equal to 1 except 0 raised to power 0. This is undefined. Okay, anything raised to power 0 is 1 except this. 0 raised to power 0, this is not defined. Okay, and then you have these indices rules, x power m into x power n. If you have bases the same and you have a whole power, if you have same base and different powers, for example, 3 raised to power 4 into 3 raised to power 9. How can you write this? If you have a product in which the bases are the same and the powers are different, what happens to the powers? They get added. You get 3 raised to power 4 plus 9, and that's 3 raised to power 13. Okay? When bases are the same and there's a product, powers get added. What about this? X raised to power m divided by x raised to power n. You have some division happening. Bases are the same, powers are different. What happens to the powers? Powers get subtracted, right? So if you have, for instance, 9 raised to power 2 over 9 raised to power 4, what do you get from that? 9 raised to power 2 minus 4, which is 9 raised to power minus 2. Make sense? And then you have this rule. This is very important. X raised to power m whole raised to power n. That means if you have something like this, 3 raised to power 2 and then whole raised to power maybe 1 over 3. How can you write this? The powers get multiplied. This power and this power, they get multiplied, and you get 3 raised to power 2 over 3 from that, right? So 2 and 1 over 3, they get multiplied. It works the other way around as well. If you have 3 raised to power 1 over 3 and then whole square, this also gives you the same thing, 3 raised to power 2 over 3. Is that okay? Then if you have something like this, xy whole power m, you have two things multiplying and there's a whole power. So for instance, you have 4 into 5 whole raised to power x. That's the same thing as saying 4 raised to power x into 5 raised to power x. Okay, if you have a whole power, that power can come and get and be placed here as the power of x and y individually like this. What if you had this instead? X plus y whole raised to power m. So instead of a product, if you had addition going on inside the brackets, इसमें क्या करेंगे? X plus y whole power n. Can this rule work here? Sorry? Property लगाएंगे कौन सी वाली? Yeah, so it depends on the power. If the power is 2, then you would say x squared plus 2xy plus y squared. If the power is 3, then you have to use some other rule. But these indices rules do not work in that case. If you have a plus or minus inside the brackets, this is not the same as x power m plus y raised to power m. Okay? This is not the same as this. When you have a product inside the brackets, the powers can come and be placed on those two things individually, but not when those things are being added or subtracted. Is that okay? Achha. Then you have x over y whole power m. The same thing. You can write this as separate powers x power m over y power m, right? And the other way around as well. If you have this, this can be written as x over y whole power m. Does that make sense? And then if you have a negative power, for example, 2 raised to a power minus 3, how can you write that? That's the same thing as saying 1 over 2 raised to a power 3. So if you take some number from the numerator to the denominator, power gets multiplied by minus 1. If you take some number from the denominator to the numerator, again, power gets multiplied by -1. So 2 power -3, that's the same thing as 1 over 2 raised to power 3. Make sense? These are all the indices rules that you know from O levels. You need to make sure that you are very comfortable using them. जब plus minus होगा दरम्यान में brackets में in particular, and you have a whole power, please make sure that you don't write that as separate powers like this. This is not correct. Okay, you can only do this when you have a product like this. Make sense? All of you are comfortable with these indices rules? Now, let's move on. You will often see expressions like these, -3 whole squared and then -3 squared. These are two different things. In the first case, the negative sign is inside the bracket. So when you evaluate the square, the result turns out to be positive, right? Because the negative is inside the square. When you square that thing, the result turns out to be positive. Now, in this case, this negative does not have the square on top of it. Negative is outside the square. So this negative sign is going to remain there. You just multiply 3 by 3. So 3 squared, that's 9. And that gives you -9. So you need to make sure that you understand this distinction, this and this. Remember the rule, the order that you've studied before in O levels, BODMAS. What did it used to say? B ब्रैकेट्स जो हैं वो पहले evaluate होंगी, उसके बाद फिर जो है उस पे जो पावर होगी उसके बाद evaluate होगी. ओके, इसको हम इस तरह भी लिखते हैं कभी कभी. P stands for parenthesis. E is exponent. Exponent means any power. Brackets पहले evaluate करते हैं, power बाद में evaluate करते हैं. Right? So bracket is supposed to be evaluated first. So in this case, for instance, you will first evaluate the bracket -3. And then you have whole power 2. All right. In the second case, there's no bracket. So you start with the exponent first. So it becomes 9, and then you have a minus sign multiplied with that. Is that okay? Any questions on this? Okay, I'll keep moving on. If you have any question at any point, please make sure to stop me and ask that question right away, ताकि आपकी कोई confusion हो तो उसी वक्त address हो जाए. Now let's do some examples. Let's say we have this expression, -x squared into -x whole raised to power 3. Now this is one common type of question. You will be given some expression and you will be asked which of the given options is equivalent to that expression, right? So now this is the expression and you have these 4 options. Which of these is equivalent to that? C? Any other answers? How do you get to C? When you take cube of any number, no, it's okay. When you take cube of any number, the minus or the plus sign remains as it is. When you take an odd power, the sign does not change. So the negative sign is going to remain as it is. If you evaluate this bracket first, that leaves you with -x cube inside. So it's -x squared into -x cube. Does that make sense? Is that okay? No? Okay, let me do it another way. Just focus on this. This evaluates to -x cube. Does that make sense? And then you have to multiply this by -x squared. These two things have to be multiplied. -x squared multiplied by -x cube. Negative and negative, they get cancelled. And you have x power 5. So it has to be C. Make sense? Okay, let's move on. Here's another example. Which of these expressions is equivalent to this? 4 raised to power x plus 1 into 3 raised to power 2x, and you are given that x is greater than 0. That's not very relevant right now. Just focus on this part. 4 raised to power x plus 1 into 3 raised to power 2x. Which of these is equivalent to that? Please make sure you have a paper in front of you, pen and paper, so you can write it down. Let me know इसमें से कौन सी हो सकती है option. You don't have to write down the whole questions. I'll be sharing this PDF with you as well, तो आप उसमें से बाद में देख सकते हैं. अभी के लिए आप सिर्फ attempt करें साथ साथ. Okay? How would you approach this? 4 raised to the power x plus 1, 3 raised to the power 2x. Remember that indices rule where it says x raised to the power m into x raised to the power n. What does that evaluate to? X power m plus n. You can also go the other way around. You can have sometimes this expression given where the powers are being added, and you can break it down into two parts like this and write it as two separate expressions that are multiplying. Now, how is that applicable here? This is 4 raised to the power x plus 1. You can actually break this thing down to two parts. How would you do that? 4 raised to the power x multiplied by 4 raised to the power 1. Is that okay? Because when you simplify this, gives you this thing back, 4 raised to the power x plus 1. So you can split that like this, 4 power x into 4 power 1. This is what you get. And here you have 3 raised to the power 2x. What do we do with this now? Look at the options that you're given. 3 of them have 4 outside here. 1 of them has 8 outside. And then the number that you have multiplying that has power x on top of that. Do you see power 2x anywhere there in the options? This power is not there in any of the options, right? 3 power 2x. Can you somehow convert this to only power x? कैसे कर सकते हैं? This is 3 raised to power 2x. We can write this as, so the logic behind that would be this rule, x power m whole power n. This gives you x power mn. You have this thing given. You can go back to this form and you can write it like this. You can say this is 3 squared whole power x. Is that okay? And now you simplify this. It gives you 4 power x into 4 power 1 into 9 power x. Just one last step after this. What can we do after this? Multiply what? 4 and 9, because they have the same powers. This is x, this is x. These two things can be multiplied together. So you get 4 into 9 whole power x, and this 4 remains outside as it is. And that gives you 36 raised to power x into 4. That's this option. You can just write it the other way around. 4 into 36 power x. That's option C here. This was a relatively trickier type of problem in indices. Okay, so you need to be able to work both ways here. All of these rules, they work both ways. If you have x power m into x power n, and that gives you x power m plus n, you can also go from the form on the right side to the form on the left side. You can break it down into two parts like this as well. So you have to be comfortable using this as well. Yeah, we use this rule. This is a plus sign, right? So we can break it down into two parts. इस पे हम ये वाला rule apply कर रहे हैं. Any questions on this? No? Okay, let's move on. Now, you have roots as well. So we've talked about powers before. Sometimes you have square root, cube root, fourth root, right? So for example, if you have square root of 25, what's that? That's 5. You can think of square root of 25 as a power as well. That's the same thing as saying 25 raised to power 1 over 2. Okay, so if you want to convert the root form to power form, you would say under root 25 is the same thing as 25 power 1 over 2. Similarly, cube root of 64. We can write this as 64 raised to a power 1 over 3. This can be written as 16 raised to a power 1 over 4. Okay, so you should be able to convert between roots and power form. So in general, If you have x and you're taking nth root of that, nth root of x, right? It's a square root hota hai, cube root hota hai, fourth root hota hai. In general, you can say this is the nth root of x that is equivalent to x power 1 over n in the power form, in the exponent form. Make sense? Now you can go the other way around as well. If you have x power 2 over 3, the power that is in the denominator, you can think of that as a cube root. So it becomes cube root of x squared. This thing, x power 2 over 3, can be written like this as well, cube root of x squared. Does that make sense? Yes. Yes, so you can break it down into two parts as well. So, for example, what you're saying is, we can write this as x squared and then whole power 1 over 3. And then that power 1 over 3 can go out and become cube root like this. So it becomes cube root of x squared. All right. So the power that is in the denominator, that can be thought of as the root of that, right? Make sense? Can we move on? Okay, let's take an example. Let's say you have this expression, x raised to power 5, fourth root of that, which is, what is that equivalent to? X power 5 over 4, right? So this 4 will go here and it becomes x power 5 over 4. So this is going to be C. Make sense? Right? Okay. Now, this is something that you are often required to do, simplifying square roots. So for instance, if you have square root of 90, put that on your calculator. This is not a perfect square. Square root of 100 is 10, square root of 81 is 9. Square root of 90 is not a perfect square. But you can simplify this. Now, there's a way of simplifying this, but I would say you don't necessarily need to know that because your calculator can do it for you. Put this on your calculator, see what you get from that. Under root 90. This gives you 3 under root 10. This is the simplified form of the square root. Okay? So sometimes you need to convert between these forms. Under root 90 can be written as 3 under root 10. 3 under root 10 can be written as under root 90. Okay? Now, how does this process actually work? 90, you think of the factors of 90 such that one of them is a perfect square. 90 can be written as 9 into 10. And that then can be written as 3 squared into 10. Now 3 squared can go outside the square root and become 3, and you have under root 10 left inside. Make sense? But your calculator can do it for you. So even if you don't know how to do it manually, make sure you have a calculator that can do it for you. All right? But these forms are equivalent. Under root 93, under root 10, it's the same number. Is that okay? All right. Now, we've talked about this before, understanding fractional exponents. So if you have x power 3 over 2, we talked about this, how we can take this 2 from the denominator to the root and make it square root of x cubed like this, right? Now, let's do an example and apply that concept here. 25 raised to power 2x divided by under root 5 whole power x. We are given that this is equivalent to 5 raised to power kx, where k is a constant. What's the value of k? So this needs to be written as 5 raised to power kx. And we need to find the value of k from that. Take 30 seconds, try this and see what you get. 25 power 2x over under root 5 power x. You need to write this whole thing as a power of 5. Anyone who's done? Okay, two of you. Try writing this thing as a power of 5. See what you get from that. G, is everyone done now? What's the value of k? 3 over 2? Any other answers? 7 over 2? 7 over 2? Okay, any other answers? 3 over 2 or 7 over 2. That's the two options that we have. Okay, let's try this. 25 raised to power 2x. न्यूमरेटर को हमने अगर 5 की पावर में लिखना है, कैसे लिख सकते हैं? We can say 5 squared whole power 2x, right? In the denominator, and inside the brackets, we can write this as 5 power 1 over 2 and then whole power x. Now in the numerator, it becomes 5 power 4x. In the denominator, we have 5 power 1 over 2 times x. And now 5 power 4x divided by 5 power 1 over 2x. So the powers get subtracted. Bases are the same. Powers are different. We subtract the powers, 4x minus 1 over 2, and that gives you 7 over 2 times x. 5 raised to the power 7 over 2 times x. Compare it with this form. Instead of k, you're getting 7 over 2. So the value of k has to be 7 over 2. Make sense? Any questions on this? No? Okay, let's move on. Let's try this now. If the square of a is equal to the cube of b, square of a is equal to the cube of b. For what value of x is under root of a raised to power x equal to b? Now you just have to convert it to mathematical form. The statement, write the corresponding mathematical form for this. Square of a, what does that mean? A squared is equal to the cube of b, b cube. That's one equation that you have. Okay. For what value of x is square root of a raised to power x equal to b? Yes. Sorry. 8 square is equal to 4 cube. And then we have to find the value. We have to find the value of x. We have to find the value of x. What can we do? That's a good start. What do you do after this? How many unknowns do we have? 3 unknowns, a, b, x. How many equations do we have? 2 equations. We are not going to be successful if we try to solve them somehow, because 3 unknowns, 2 equations, that doesn't work. Can you somehow go from this form to this form? If a square is equal to b cube, What is b equal to? If you make b the subject here, what do you get on the other side? A raised to the power 2 over 3. So, okay, let me do it this way. Take 1 over 3 power on both sides. Make sense? 1 over 3 power on both sides. On the left side, you get a raised to the power 2 over 3. On the right side, you have b. So b equals a raised to the power 2 over 3. Okay. Yeah. Yeah. Yeah, you're right about that. So this is a square root. This will also work actually. We can convert it to that form, but generally, let me just confirm if there's a missing piece here. No. Okay, so assuming this question is correct, let's say we have to do it this way. How can we do it? Here we have b equal to square root of a raised to the power x, and here we have b equal to a raised to the power 2 over 3. Cube root of a square. Okay, but on the right side, this is supposed to be a square root, right? If b is equal to this and b is equal to this, can we just equate them? Right? Okay, so let's do that. A raised to power 2 over 3, that equals square root of a raised to power x. Now, what does the right side become? A raised to power x over 2. And this is a raised to power 2 over 3. Can you find the value of x from this? X over 2 equals 2 over 3. And the value of x becomes 4 over 3. That's the value of x that we get. Let me repeat. So we were given that a square is equal to b cube. And we were given that square root of a raised to power x is equal to b. To compare both equations, we basically made this b cube b as well. How did we do that? By taking cube root on both sides. And that gave us b equal to this. Now b equals a raised to power x square root, and b equals a raised to power 2 over 3. Just equate both of them, solve that, and that gives you the value of x. Does that make sense? No problems? Now this was a relatively harder problem. It was not that straightforward. So you made two equations, eliminated b from that, and then compared these two powers of a like this. उस तरह भी सोच सकते हैं, उस तरह भी सोच सकते हैं. Okay, so this is one way of doing this. Now, Minail suggested that we could actually put some values of a and b in this case. But that only works if we can figure out those numbers like this, like you did. So this was a square equals b cube. What you're saying is this equation satisfies if the value of a is 8 and the value of b is 4. This is one set of values for which this equation satisfies. If you use these values of a and b, you can use these to find the value of x there. You can try that and see what that gives you. 8 raised to the power x, and then square root of that, it becomes x over 2 equals 4. You can write that as a power of 2. This becomes 2 raised to the power 3x over 2, and this is 2 raised to the power 2. 3x over 2 equal to 2, and x is equal to 4 over 3. This could be another way of thinking about this. If you can figure out one pair of values for A and B like this, right? But you cannot always do this. Sometimes it works, sometimes it doesn't. So the other method that we did, that was the general method that would work for any kind of problem like this. Okay, let's move on. This is fairly straightforward now. Which of the following is equivalent to x squared whole power 3 over 4? What should this be? Let's try to simplify this. What does it? What does this give us? X squared. So you just multiply these two powers. 2 into 3 over 4. What's that? 3 over 2, right? 2 into 3 over 4, that's 6 over 4 or 3 over 2. Now, which of these powers is the same as 3 over 2? This is 2 over 3. This is 1 over 4. This is 1 over 2. What's B? B is x power 1 multiplied by x power 1 over 2. What does that become? X power 3 over 2. That's equivalent to that. Yeah, you can do that. It doesn't cancel out, but what you're saying is under root x whole squared into under root x, and that gives us under root x whole cube, which is x power 3 over 2. Yeah. Does this make sense? No? Where are you stuck? Okay, so just a strategy that you should know as well. If you can't figure out what the correct answer is, start eliminating the wrong answers. You want x power 3 over 2. Okay? The other three are very simple to figure out, right? This is power 1 over 2, that's not correct. This is power 2 over 3, that's not correct. This is power 1 over 4, that's also not correct. Okay? That leaves you with only one choice, right? Let's try to understand why this works then. X into under root x. Under root x can be written as x power 1 over 2. And then you have x power 1 into x power 1 over 2. What happens to the powers? X power 1 plus 1 over 2. Powers get added. And that is x power 3 over 2. And that's what we were looking for.